see the plots, but I'll walk through it, and then I'll skip perhaps through the things which have plots, and then I'll cover those in like an online screencast. So you can also use a different package to do this, and it's a C tree. And again, you'll see the trees magically appearing when I make the slides. And this is not full screen. But let's move perhaps to a continuous example. So sometimes, now we talked about examples with categorical cases, so supplement and dose, but sometimes you will have continuous variables which also interact. And we can go back to the salaries database, and then you can have you can have an interaction between, let's say, categorical and continuous, but also continuous interactions. So this is just me calculating monthly salary, which you've also done in part of the exercise, and then me centering the year since PhD variable, and then renaming, because one is called sex and I wanted to call it gender, so that's why I renamed it. What you can then do is just interactions with continuous variables are not ANOVAs, or we don't use CAR for that, because this type of sums of square partitioning doesn't really apply, because you don't have a factorial design. You don't have A type, A and B, and so one is a continuous and the other one is a categorical. So it's just a linear model. But it's the same type of notation, so it's gender times year since PhD centered, and then data from salaries. And then you get the summary for interactions, and you can already see here that there's no interaction going on there. And you use drop 1 to get the f-tests again for those. You can again try to get post-hoc effects, and you can plot those, but the plot is not here. And then you can also test interactions if you have, like, let's say 3 levels. It's not very useful here. But you can test also in the post-hoc things whether those post-hocs are significant. And you use the phia package to do that. Again, plots, you won't be able to see it, but it was a very beautiful plot. We'll do that later, because I'll just skip everything regarding plots, because I wasn't able to show you plots. But you can again do permutation tests. So I talked to you about permutation tests, which are quite nice because they do all this type of shuffles. So and it's just that you don't have to worry about any type of assumptions, except for the fact that everything should still be non-independent. But basically, it's a premise: we shuffle our data. Do we still find evidence for an effect? And if that's the case, then perhaps there is a real effect. So you can, so if some of the assumptions are violated, you can use a different package to permute your data, and then you don't have to worry about homogeneity, variance, or some other issues per se. And you can use permutation tests. So we use a different package. We use vegan, and then it's the same type of equation as for this, but now we use Adonis 2. And that's Adonis is for analysis of distance something. It's not that important. It's just the abbreviation for the function. You have to say margin, and that's because you want type 3 type of tests. And we have to specify the method. So Euclidean, and that's because it will calculate distances. Very long story, but this package is developed by ecologists, and some species have very different numbers and distributions. So the default is not suitable for psychology experiments. So you have to change it to Euclidean if your dependent is continuous. And then in this case, you also find a significant interaction when you do 999 shuffles in your data. You still find a significant effect. Yeah. So continuous times continuous interactions is the final type. So you might have, let's say, neuroticism and state anxiety, and you want to see that predicts depression, but you think these two might interact. So then you would take the multiplication of those two. And so here we want to find out a relationship between neuroticism and, it's actually neuroticism and depression. No, does the relationship between neuroticism and depression depend on state anxiety? So does that slope change as a function of this one? Yeah. So does the relationship between these two changed as a function of that third one. Yeah. So here I haven't centered, but normally you would center to avoid some type of multicollinearity issues, which I've talked to you about in regression. But just to give you an example, I've not done that. But you know by now, centering, subtracting the mean, and then using that variable. Any questions? I'm going at perhaps high pace, but so we load psych to get the data, and that's just because it's the epi.bfi. That's why I loaded it, and then it's a linear model, and that's the type of thing for the interaction again. And then you can use summary to summarize the object, and you can find a significant interaction between state anxiety and neuroticism on depression in this case. Yeah. Again, plots won't work. But what you are then usually interested in is in shifts of one standard deviation above or below. And we can then also ask R to draw confidence bands for one standard deviation above the mean, and one standard deviation below the mean, to see how the relationship varies as a function of a score. Again, a pity, but I'll try and fix it. You might have heard of something called simple slopes analysis. So this is just finding whether this slope is significant in those three types of groups. So whether it's significant at the mean, significant at one standard deviation above, and one standard deviation below. And you use the jtools package to do that for you. So that will basically tell you, is that trend significant in one group, or is it not? And is it significant in the other group? So here you find in all three groups it's significant, but you can see that the slope of this one is only half the slope of that one. Yeah? So it's a much bigger effect for people one standard deviation above than for people one standard deviation below. And that's also what the chart would have shown. So basically the angle of that regression line varies depending on whether people are scoring high on state anxiety or low on state anxiety. So what this actually does is arbitrarily divides your data into bins, like one standard deviation above, mean, one standard deviation below. But you can also use actually a way of calculating the entire range for which the slopes would be significant, and that's known as the Johnson-Neyman interval. Because now we might have been unlucky that if we had shifted like 5% to the left or 5% to the right, the slope would be no longer significant. So the Johnson-Neyman interval sort of tells us the entire range over which it's significant or insignificant. And so this then prints you some type of result. So it's Johnson_Neyman from the jtools package again. The model, you have to tell what the predictor is, you have to tell it what the moderator is. So the moderator is state anxiety, it's where we think based on high, medium, low, the slope will vary. And so it says that the slope of epi-ner, which is this neuroticism variable, is significant when state anxiety is outside of this interval. So that's the range at which it's the slope is significant. And then it also prints you the range of those. So nearly over the entire range which you found capture it's significant, except at a very, very low range, because there's still some overlap between 21 and 79 and 22.19, but in all other cases the slope is significant. Yeah, so that's useful because then you're not dependent on chunking your data into one standard deviation below the mean and one standard deviation above. It just tells you all the places where it's significant. And I had a plot to show you what it looks like, but again that doesn't work. So if you have problems with heteroscedasticity, which is the same as homogeneity of variance, but because now we're dealing with linear models, you test out those type of things. You can also do it in a robust type of way. And all the differences is you have to load the packages which do this, and then that robust is true. And then in this case, it will take care of the assumption of heteroscedasticity. So heteroscedasticity, again, is the assumption that the homoscedasticity is the assumption that the errors are constant, but you can have funnels in your errors, and that means all sorts of problems. And you can correct for that. And in this case, correction doesn't really change any type of the results. You can still see this range is more or less the same as we had before for the Johnson-Neyman interval. We can still see that the slopes are roughly the same in terms of significance and the same type of estimates like 0.286, 0.637. This hasn't changed in our conclusions anyway. Yeah. Plot. So I'll skip that. So repeated measures ANOVA. Actually, you had an example, Mark, if I'm not mistaken, of repeated measures ANOVA design for your thesis.
One that you explained to me.
What?
The one that you explained.
Yes.
Yeah.
Yeah. So just say what the design was of your study and what would an interaction be of your study.
So I was testing mindfulness interventions after acute stressor. So I had 4 interventions for control. And I was taking systolic measures before the stressor and at 3 time points before the stressor, after the stressor, and after the intervention. But I didn't test that. The example that you mentioned was maybe comparing different groups, those who are more familiar with multitasking, self-esteem, stressors, or tasking actively at the same time, against those who aren't, or those who go to work, who are maybe more used to multitasking, against those who aren't.
Or perhaps people are open to mindfulness intervention. Perhaps it doesn't work for if people are very resistant or closed-minded.
Yeah.
Then so there are examples where you would have repeated measures type of design, as in Mark's design, where you would have the same thing measured like heart rate or something else across different things, and you would have interactions, and some of these interactions would be within. So something changes within the intervention. So, for example, the stimuli change, or the intervention method changes, or something else. But there could be also an effect based on the person, like gender, work experience, and so in that case, we would have within type of interactions. So that's the final type of interactions I want to talk to you about today. And so they also apply to repeated measures ANOVA designs. And so we've talked about an example and talked about an interaction. And again, this is sort of how you would go about doing this. And so I have an example here from a hypothetical language acquisition study, which I found on this website. And we're interested in children who are raised bilingually, and where one of the language they speak is the home language, and the other one is used in their school. And MLU is the mean length of utterance. So basically, how long the sentences they form. And so in this case, you can have a look at the data here. We use the easy package, and we say this is the data, the bilingual data. This is the mean length of utterance, our dependent variable. We have the ID, which is the subject, and we have things varying within the individual, which is their age. So if you measure them at different time points, you can see how they progress. And then you can have the language also, which they use. Do they use it as a home language or as a school language? And between you can have gender, for example, which stays constant across all these different measuring points. Yeah. And so what you would have to do is you would have to remember the types of so this is how you do it, type of 3. So that's the important thing. You have to remember every single time to specify the type of error you want. So I'll keep on hammering this home. And this is the type of output you would get. So again, the ANOVA object is a list, and will also print all sorts of other things. But we're interested in this case in the ANOVA table. And so in this case, would be a 3-way interaction. So this is between factor, but these are 2 within factors. And there's no significant effect here because we can look at the stars. So there's no significant effect there for the things, and you can actually see it's a very, very small effect size. So there's no effect there of gender times language times age. What you do have is a language and age type effect, and so there were 3 age stages. So as you might expect, people's utterances go up as they age, and you can find out the effect of language, whether it's home or school, when you look at the actual data. It will also print what you remember for repeated measures ANOVA is Mockley's test of sphericity, and in this case we have nothing to worry about because none of them are significant. But if they are, you would use corrected measures. So you would have sphericity corrected measures, like you've heard of greenhouse geyser perhaps, or Hohenfeld. but basically it's correcting the tests which you've done for the fact that the sphericity assumption is violated. So if everything is hunky-dory, you don't have to worry about them and you don't have to run them. But if it is violated, ANOVA will print you the sphericity corrected measures. And the most common one are the Geyser correction and the Heinfeld correction. And you can read more about them. Some of them have benefits to other ones, and it again depends on your design, whether you have a very powerful design or whether you want to be on the side of caution or not. That sort of are the choices you have to make. So in this case, we call from the list the sphericity corrections, and we'll print you this, and it sort of shows that the age type of things is also significant if you sphericity corrected, and it just prints all the effects there for those variables. So I'll go back and correct the charts. I've had an exercise for you which is based on the Chase ITV quiz shows. I coded 50 episodes of the Chase, and you're going to do some tests with that. And I want you to test the assumptions for a 2 times 5 ANOVA. So basically, I want to find out if the gender of the contestant and the opponent which they play, if that influences the highest offer made by the chaser. So, for example, chases would be, if one chase would be particularly lenient towards men, or particularly, so that's the type of test we want to do. I want you to conduct the 2 by 5 ANOVA. If you really want to pick a different variable, that's also fine. But conduct the 2 by 5 ANOVA and then calculate the post-hoc contrasts, and then make a violin plot, and I'll show you how to do that. And you've done that before also, showing these type of results. And then I also want you to do 2 by 2 ANOVA, where 1 is the continuous, which is the age of the contestant, on chosen, which is the amount which they've picked. So I want you to make a plot showing that interaction, and I want you to then do some bonus things if you still feel like it. After playing with the Chase data, we go back to the salaries data and test the interaction for effect for years of service and years since PhD on monthly salary. So you've used that data set before, and I would like you to calculate the Johnson-Neyman interval range for that. And if you want, you can also then conduct a permutation analysis for the 2 type 5 ANOVA, which I've done, and then build a tree, which I haven't gone into detail, but I'll talk to you about the screencast. So I'll make a screencast where I talk about all the slides with graphs on them. Yeah, I'm sorry that hasn't worked out, and I actually tested it yesterday on my desktop and it worked, but I should have checked this morning. So, any questions at this stage? So we finished early for a change. So if you want, you can start working on the assignments here, or you can go and have a break. I'm not sure what you feel like. Probably break. Yeah. And if you haven't worked on the assignments before, now is really the time to start submitting assignments and try to get feedback and working on your assignments. So I'll make sure I'll have the assignment thing open. I'll make sure you have the data available. And I'll see you in 2 weeks' time. And intermittent questions post on the discussion board, and I'll try and respond fairly quickly, or perhaps somebody else can respond. No questions? Everybody's going to go? If you're going to stay and practice the exercises, then I'll stay. But if not, then I'm going to go as well. I think it was quite a lot to take in, so. Okay, I'll have a look.